On a clear night, you'll be able to see numerous stars twinkling in the sky. The vast surrounding space is called the universe. The universe includes everything that exists. The most distant stars, planets, satellites, as well as our own Earth and all the objects on it. Thus, in order to study the constitution of this universe, we have to first discuss the objects like galaxies, stars, planets, and satellites, etc., which are found in the universe.
Certain terms are coming. What are those terms?
Universe,
Galaxy, stars,
constellation.
planets, satellites.
By one.
Sir, galaxies,
Galaxies,
universe,
universe,
stars,
Planets.
sir, stars, planets, and satellites.
Sir, even
Objects.
asteroids and
They're
meteors.
objects.
Comets, planets.
Right now, sir is telling.
then comet.
Earth.
Meteors.
Earth was
Asteroids.
Asteroids.
COMET, right? Comet.
Yes,
Yes, a comet, not comeo.
Okay, then
Earth was
meteors.
mentioned, sir, as a
Asteroid.
main one, sir.
Okay,
Asteroids.
so those things we are going to learn.
The moon. The moon appears to be the brightest of all other celestial objects after the sun. You can see the whole of the moon on a full moon day. How are you able to see the moon? It is because it reflects the light of the sun. The moon does not produce its own light, but looks bright because it reflects the light from the sun. Think of the sun as a light bulb, and the moon as a mirror, reflecting light from the light bulb. The moon revolves around the earth and also around the sun along with the earth. The moon completes one revolution around the earth in 27.3 days. In the meantime, the earth moves ahead in its orbit. Thus, from the earth, the moon appears to complete one revolution between one moon day and the next in 29.5 days. You know that a lunar eclipse may occur on some full moon days. The moon. The moon appears to be the brightest of all other celestial objects after the sun. You can see the whole of the moon on a full moon day. How are you able to see the moon? It is because it reflects the light of the sun. The moon does not produce its own light, but looks bright because it reflects the light from the sun. Think of the sun as a light bulb, and the moon as a mirror, reflecting light from the light bulb. The moon revolves around the earth and also around the sun along with the earth. The moon completes one revolution around the earth in 27.3 days.
Okay, just one point it has mentioned here.
In 20. Around the moon completes one revolution.
Right? Moon revolves around the earth, right? We will read one statement. The moon completes one revolution around the earth in 27.3 days. Right? How much time it takes? 27.3 days.
10.3 days.
The earth moves ahead in its orbit. Thus, from the earth, the moon appears to complete one revolution between one new moon day and the next in 29.5 days. Now tell me one thing, if moon is revolving around the earth, then moon and earth together, they will be revolving around the sun also?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Good.
Revolution around the earth in 27.3 days. In the meantime,
Stars and solar
the earth
system started
moves ahead in its
so
orbit.
fast.
Thus, from the Earth, the Moon appears to complete one revolution
Okay,
between
mute
one
yourselves.
moon day and the next in 29.5 days. You know that a lunar eclipse may occur on some full moon days. Phases of the Moon. New Moon. During a new moon, we can see no portion of the moon's surface that is lit. We see only the dark side of the moon.
New moon means
New moon, sir, means like new moon is about to come, sir. Like it's like we cannot see. We can only see the dark side of the moon.
new moon. New moon means no moon. Okay?
Yes, sir. No moon.
कोई moon नहीं है. Total dark side.
So new moon
This
occurs when the moon is between the earth and the sun.
typically marks the beginning of the lunar cycle, which lasts 29.5 days. The moon is between the Earth and the Sun in its orbit. Waxing crescent. During the waxing crescent phase, we see on the right side a small sliver of the lit moon. First quarter. During the first quarter phase, we see the right half of the lit moon. The moon and Earth are now side by side in their orbits around the Sun. Waxing gibbous. During the waxing gibbous phase, we see almost the entire right side of the lit moon. Full moon. During a full moon, we see the entire half of the moon's surface that is lit. The moon is positioned behind the Earth and the Sun. Waning gibbous. During the waning gibbous phase, we see almost the entire left side of the lit moon. Last quarter. During the last quarter phase, we see the left half of the moon lit. The moon and Earth are now side by side in their orbits around the Sun. Waning crescent. During the waning crescent phase, we see on the left side a small sliver of the lit moon.
Yes, sir.
Up into the sky on a clear night, most likely you will notice. You will also notice that it doesn't look the same every night. Welcome to Moo Moo Math and Science and the phases of the moon. The moon revolves around the Earth roughly every 27 days. As it revolves around the Earth, it goes through phases. Here's what these phases look like. But why does this happen? The Sun, Earth, and Moon, along with their movements, causes the phases of the moon. The Earth revolves around the Sun, and the moon revolves around the Earth. Let's take a look at this. The moon cycle, or lunar cycle, begins at new moon. Here's the alignment of new moon. And here's what new moon looks like from Earth. And yes, it is very dark. The moon travels roughly 13 degrees in 24 hours. So after roughly 3.5 days, the moon has moved 45 degrees and is at waxing crescent. Here's the alignment. Waxing means that the sunlight is getting larger and crescent is the shape. And here's what it looks like. In 7 days, the moon has now traveled 90 degrees and is at first quarter. Here's the alignment. Remember, the sunlight is always on the right in first quarter. I remember to be first, you must be right, and the light is on the right. Also, the shadow moves from right to left. In an additional 3.5 days, it has now traveled 135 degrees and is at waxing gibbous. Check out this alignment. Gibbous is the shape, and remember, waxing means the light portion is growing. After 14 days since new moon, the moon has now traveled 180 degrees and is at full moon. Here's the alignment, and here's what a full moon looks like. After another 3.5 days, the moon is now at waning gibbous. Here's the alignment. Waning means the light is getting smaller. And here's what it looks like from Earth. Again, remember the shadow moves from right to left. After 21 days, the moon has now traveled 270 degrees and is at last quarter. Here's the alignment. The light is now on the left. And I remember, if you got last, you got left behind. After roughly 24 days, the moon is now at waning crescent. Remember, waning means the light is getting smaller. And the sun, earth, and moon alignment looks like this. And finally, after roughly 27 days, the moon is now back at new moon, and the lunar cycle will start over again. If you'd like to know more about the phase,
Hello, kids. Space Pro Planetarium welcomes you to this show on the lunar cycle. Have you ever seen the moon on a clear night sky? If you've observed the moon carefully, you would have seen that it doesn't look the same on all nights. On some nights, the moon is big and round, and on others, it is a thin slice of light in the sky. Have you ever wondered why the moon looks different every night? You will be surprised to know that the way our moon looks to us is not as much about the moon as it is about the sun and the earth. Strange, isn't it? Let's understand how. The moon always has a spherical shape like a basketball, but it doesn't always look that way to us. We always see exactly half of the moon. Some of the time, that half is lit by the sun and we see it. At other times, it isn't lit by the sun at all, and we can't see it. Most of the time, the part of the moon that we see is partially lit by the sun and partially shadowed. The moon looks different to us depending on where it is in orbit. Remember, the moon revolves around the Earth once every 29 days. In other words, once a month. As the moon moves around our Earth, we see a different part of it lit by the sun. When the moon is on one side of the Earth and the sun is on the other, we see one half of the moon that is bright with sunlight. This moon is called the full moon because we see a full round circle. Each of the positions of the moon in orbit has a name. Let's look at what they are. When less than half of the moon is lit by the sun, it is called a crescent. When more than half of the moon is lit by the sun, it is called a gibbous. Waxing gibbous indicates the part of the moon that is lit and growing, whereas waning gibbous is the part of the moon that is lit and shrinking. Based on what we just learned, let's look at the different phases of the moon. There are 8 phases in all. We'll now explore each phase of the moon. The lunar cycle begins with the new moon phase, when the moon is not visible from the Earth. This is because the half of the moon that faces away from the Earth is lit, and we only see the dark half. During the waxing crescent phase, we begin to see a very small part of the moon lit by the sun, but most of it is still shadowed. In the first quarter phase, only one half of the moon is visible from the Earth. This is because the right half of the moon appears lit, and the left side of the moon is still shadowed. In the waxing gibbous phase, more than half of the moon appears lit by the sun. When you see a waxing gibbous moon, you know that a full moon is just a few days away. During the full moon phase, the moon is on one side of the Earth and the sun is on the other. The sun illuminates the half of the moon that faces the Earth directly, and the moon looks like a full round circle. In the waning gibbous phase, the other half of the moon is lit by the sun, and we see it looking like a little less than a whole circle. The waning gibbous moon looks like it is shrinking, doesn't it? But it's not. In the third quarter phase, the left half of the moon appears lit, and the right side of the moon appears dark. During the waning crescent phase, the moon looks like a crescent. This moon signals the beginning of a new cycle, and means that you will see the new moon in a few days. Here is a quick quiz on the lunar cycle. You need to identify the phases of the lunar cycle based on pictures of the moon you see on screen.
Third quarter phase. Waxing gibbous phase. Full moon phase. Waning crescent phase. Waning gibbous phase. Waxing crescent phase.
New moon.
New moon phase.
Let's now try another quiz. Drag the correct picture of the moon to each phase and then click Submit.
New moon. Waxing crescent. First quarter.
So it will left side, no sir.
Waxing gibbous. Full moon. Waning gibbous. Third quarter. Waning crescent.
That's correct.
Yes.
That completes our show. You will now be able to recognize
Sir,
The waning crescent can only be seen in the early morning in the east, while the waxing crescent can only be seen in the early evening in the west. The moon travels around the Earth counterclockwise, moving from west to east. This movement around the Earth is known as the orbit of the moon. The orbital period of the moon can be expressed in either sidereal or synodic months. One sidereal month is the time it takes for the moon to orbit the Earth once and return to the same position in the celestial sphere. A sidereal month is 27.3 days and represents the actual orbital period of the moon. One synodic month is the time it takes for the moon to go from new moon to new moon, or full moon to full moon. A synodic month is 29.5 days and is known as the lunar month. The reason a sidereal month and a synodic month are different in length is because as the moon orbits the Earth also orbits the sun in the same direction. The moon also rotates on its axis from west to east. It takes the moon 27.3 days to rotate once. You may have noticed that this is the same duration as the sidereal orbital period. Synchronous rotation is the term used to refer to the fact that the moon's orbital period and rotational period are the same. Let's assume we are looking down from above at the moon orbiting the Earth. The moon is above the Earth, and the side facing the Earth is marked with a red flag. If the moon did not rotate, we would be able to see all the sides of the moon from the Earth. But because the moon rotates, and its period of rotation is the same as its orbital period, we are only able to see one side of the moon from the Earth. On the other hand, if we were standing on the moon, on the side of the moon where the red flag is, and looking down on Earth, it would be possible to see all sides of the Earth. At certain times during the moon's rotation, the sun, moon, and Earth are aligned. In what is called a solar eclipse, the sun is hidden from view by the moon. At other times, the sun, Earth, and moon are aligned. When this happens, the moon enters the Earth's shadow and is hidden from view. This phenomenon is called a lunar eclipse. When a solar eclipse is viewed by a person in the northern hemisphere, the sun darkens and brightens from right to left. In a lunar eclipse, the moon darkens and brightens from left to right. We don't see solar and lunar eclipses every month. Why do you think that is? The path of the sun's annual motion is called the ecliptic, and the moon orbits along its own orbital plane. The sun's path of annual motion is parallel to the Earth's orbital plane, but the moon's orbital plane is tilted at around 5 degrees. This is why we don't see solar and lunar eclipses every time there is a new moon or full moon. There are various types of solar and lunar eclipses. First, we have full solar eclipses, partial solar eclipses, and annular solar eclipses. The type of solar eclipse is determined by the position of the moon's shadow. Before we go on, we must first discuss the idea of the umbra and the penumbra. The umbra is the innermost and darkest part of a shadow, where the light source is completely blocked. The penumbra is the region where only part of the light source is blocked. The penumbra is the lighter part of a shadow. In a full solar eclipse, the umbra of the moon completely blocks out the sun. In a partial solar eclipse, the sun is only partially blocked by the penumbra of the moon. An annular eclipse occurs when the apparent diameter of the moon is less than the apparent diameter of the sun. The moon is unable to completely block out the sun, and the edge of the sun is visible. Annular eclipses occur when there is a great distance between the moon and the earth. There are only two types of lunar eclipses: full lunar eclipses and partial lunar eclipses. In a full lunar eclipse, the entire moon enters the umbra of the earth. While the moon should not technically be visible when it is in the earth's shadow, the surface is faintly visible because the moon reflects back some of the sunlight that is reflected and scattered in the earth's atmosphere. Most blue light is scattered in the earth's atmosphere and does not reach the moon. This is why when there is a full lunar eclipse, the moon appears to be a faint red. In a partial lunar eclipse, only part of the moon enters the umbra of the earth. According to folklore in some regions, a rabbit or man living on the moon is the reason why the moon seems to change shape every night. But as we've learned today, changes in the shape of the moon are a result of how the moon moves. Now, our next session will be the last of the Why series.